As we have discussed a few problems, few numericals in the previous video, let's continue the other numericals. We have used equations of motion v is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as in the previous video, whatever the numericals were there. Now let's continue with a little variation in the problems. Here an object is thrown vertically upwards to a height of 10 meters. Calculate its velocity with which it was thrown upward, time taken by the object to reach the highest point. That means here an object is thrown vertically upwards to a height of 10 meters, for example ball or anything is thrown against gravity. Then as I told you in previous video about problems I introduced there, acceleration due to gravity, so A will be taken as G. When it is against gravity, we take minus 9.8. 9.8 is standard. If it is against gravity, motion is against gravity, then it is minus 9.8. So S is equal to 10 meters here, and v is equal to 0.0 meters per second, final velocity is 0. G is equal to minus 9.8 meters per second square. So using this equation, v square minus u square is 2gs. Actually it is 2as, but when these kind of problems comes like against gravity or when gravity is involved, then we take 2gs instead of a g. So after solving we get u is equal to 14 meters per second. Then we use this u in v is equal to u plus gt. So where t is equal to v minus u by g. So v value we know it is 0. So u will be 14. So it will be 14 by 9.8. Here it is minus, again here it's minus, so it will become plus. So 14 by 9.8. 9.8 will be 1.43 seconds as it is time. Now next problem, a stone thrown vertically upwards takes 3 seconds to attain a maximum height. This is similar, but here the formulas, equations used are different. So initial velocity of a stone and maximum height attained by the stone we need to calculate. Given is final velocity is equal to 0. Then gravity, as we know it is against, thrown vertically upwards. So minus 9.8 meters per second square. Time given is 3 seconds. So we use v is equal to u plus at to find out what is u. As we have time, how to use this? As we have time, we have acceleration. So only u we need to find, as rest 3 are with us. So we are using v is equal to u plus at. Then followed by the equation s is equal to ut plus half. Actually here and here we need to use gt and gt square because it is acceleration due to gravity. After substituting all the values, we get s is equal to 132.3. So this is a problem similar to the previous one where the stone or any body is thrown against the gravity, and we are taking two equations, v is equal to u plus gt and s is equal to ut plus half gt square. So when we are doing problems, first note down the given data properly, then accordingly how to choose the formula. When 3 or in the formula whatever, suppose if for example v, u, g, t are there, we know what is v, what is g, what is t. Only u we have to find out. In this type of cases, we can use v is equal to gt. But if we use any other things to find out any other formula, for example, s is equal to ut plus half gt square is there. We cannot use this equation here. Why? Because yes, we don't know. Two things we don't know here, s and u. So in that way, we need to choose the equation, appropriate equation. This is very easy problem, but here conversion of kilometers to meters per second is needed, kilometers per hour to meters per second. So I have taken this problem. A bus decreases its speed from 80 kilometers to 60 kilometers per hour, 80 kilometers per hour to 60 kilometers per hour in 5 seconds. Find the acceleration of the bus. So initial velocity we know, final velocity we know. Just convert into meter per second by multiplying with 5 by 18. This is important. Then we use equation v is equal to u plus at. As we know what is v, we know what is u, we know time is 5 seconds, not mentioned here, time is 5 seconds. So we can easily solve this. Acceleration is minus 1.1 meter per second square, means as the bus started at 80 kilometers per hour and decreased to 60 kilometers per hour, so we are getting acceleration negative, that is retardation. So with this we have completed different numericals of different types of numericals by taking all these equations.